Hello everyone, welcome back to my channel. So this is the continuation of classes on amines. In our last session, we have given discussion regarding some of the chemical reactions of amines. So we have said that in amines, we can look over into three different kinds of amines. One is primary, secondary and tertiary amines. But one question may come to our mind, that is, if an amine is given to you and if it is asked, can you tell me which class of amine is, means whether the amine which is given to you is a primary, secondary or tertiary amine. How to say? And it is highly impossible to say by looking over with our naked eye, it is a primary, secondary or tertiary amine. It is not possible to say. But through performing some chemical reactions, by performing some chemical test, it is possible to judge whether a given amine is a primary, secondary or tertiary amines. So now in this video we shall see one of the best tests we can use for distinguishing isomeric amines. So in order to distinguish the isomeric amines, the very best test we go with is carbylamine reaction. This carbylamine reaction is also called with some other name, and it is called as Hofmann isonitrile synthesis. So here I have written the word isonitrile. So it's the IUPAC name. It is given for the material isocyanate. So isocyanates are commonly called as isonitriles in the field in the IUPAC system. So by looking over to the heading itself, you can come to know that in carbylamine reaction, we observe the formation of isonitriles. And first, we shall see how this carbylamine reaction will be useful in predicting whether a given amine is primary, secondary or tertiary amines. In strictly speaking, the carbylamine reaction, which is also called as Hofmann isonitrile synthesis, is preferably used to identify the primary amine. That means this carbylamine reaction preferably gives answer only for primary amine, and that primary amine may be aliphatic or aromatic. But this carbylamine reaction will not give answer for secondary and tertiary amines. And at the last of the discussion, we shall say why this carbylamine reaction will not give answer for secondary and tertiary amine, why only answers for primary amines. So firstly, we shall see the basic stuff of carbylamine reaction. So in this carbylamine reaction, as I said, if you consider a primary amine, so which can be written as or NH2. So R can be either alkyl group or it can be aryl group. That is what I said in case of carbylamine reaction, the answer will be given for both aliphatic as well as for aromatic amines. So when you consider a primary amine, and this primary amine will be reacted with chloroform, which is having the formulae CHCl3 along with potassium hydroxide, which is prepared in alcoholic medium. So when a primary amine is made to react with chloroform and alcoholic KOH, it results in the formation of RNC. So that what we have obtained, as we have written in the heading, that is isonitrile, nothing but isocyanates. So we are going to get corresponding isocyanides, and along with the formation of isocyanides, we will be getting the KCl along with the elimination of water. This is the basic reaction for carbylamine reaction, that is a primary amine which can be aliphatic or aromatic, it reacts with chloroform and alcoholic KOH, results in the formation of isocyanides as major product along with KCl and water. One question may come to our mind, that is how we are going to judge whether the isocyanide formation is happened or not. So for that, it's a very easier way to predict whether the isocyanide formation is happened or not if the taken amine is the primary amine with chloroform and alcoholic KOH, soon formation of isocyanide, you are going to get a foul smell. So generation of foul smell upon reaction of an amine with chloroform and KOH says that the amine that we have taken is a primary amine but not secondary or tertiary amine. So if the foul smell formation is not occurred when the given amine is reacted with chloroform and alcoholic KOH, that indicates the amine which is considered is not primary but it can be secondary or tertiary amine. To judge whether it is a secondary or tertiary, we will be going with some other test that we shall discuss in the next video of the same topic. So now we shall bound ourselves for only carbylamine reaction. So one question may comes to our mind, how this isocyanide formation is taking place, and for that shall go with a detailed mechanism of carbylamine reaction. Okay, so we have given a general reaction for carbylamine reaction. Shall take some 1 or 2 examples to explain the carbylamine reaction. That is, we shall perform some reactions by considering both aliphatic as well as aromatic primary amines. So here I have given the general reaction for carbylamine reaction for 1 mole of primary amine. Okay, so here I have written a general reaction of carbylamine reaction. For 1 mole of primary amine, 1 mole of chloroform will be utilized and there will be consumption of 3 moles of alcoholic potash, so that we will get 1 mole of corresponding isocyanide or isonitrile, and there will be formation of 3 moles of potassium chloride with the elimination of 3 moles of water. So this is the complete balanced chemical equation for carbylamine reaction. And now we shall see some simple examples for carbylamine reaction. So at the place of R, we shall consider CH3 and H2. So methyl amine, or if you go with IUPAC system, here we have only 1 carbon atom, so that the IUPAC name of this amine is methanamine. So this methanamine, upon reaction with chloroform, that is CHCl3, with the consumption of 3 moles of alcoholic KOH, it results in the formation of CH3NC plus 3 moles of KCl plus 3 moles of water. So 1 mole of methanamine reacts with chloroform and 3 moles of alcoholic KOH, so that it results in the formation of methyl isocyanide, so which will be observed or which will be indicated by the formation of foul smell. And this is the example that we have taken by considering an alkyl group over here. So it is the formation of alkyl isocyanide by considering aliphatic primary amine. Similarly, we shall go with the aromatic primary amine. So the very best example for aromatic primary amine is benzene amine, which can be commonly called as aniline. So aniline, on reaction with chloroform CHCl3 by consuming 3 moles of alcoholic potassium hydroxide, it results in the formation of corresponding isocyanide. So NC plus 3 moles of KCl plus 3 moles of water. So aniline on carbylamine reaction results in the formation of phenyl isocyanide. This is in common system. In IUPAC system, we can call this material as benzo isonitrile. This is the IUPAC name of it. So the formation of methyl isocyanide when we have considered methanamine, or formation of phenyl isocyanide upon reacting chloroform and potassium hydroxide with aniline will be observed by looking over to the development of an intolerable odor or a foul smell. So When the methyl isocyanide or phenyl isocyanide is formed, we observe the development of an foul smell that clearly indicates that the amine which we have taken for carbylamine reaction is a primary amine and not secondary and tertiary amines. So that this carbylamine reaction is preferably answers for only primary amines and not for secondary amines. But one question may comes to our mind, how actually the reaction pathway will occur upon reaction of a primary amine with chloroform and alcoholic KOH. So that can be known, that can be come to know only with the mechanistic pathway of the reaction. So now we shall see the detailed mechanism of this carbylamine reaction, and by looking over to the mechanism we shall explain why can't we expect answer of carbylamine reaction with the secondary and tertiary amines. So now we shall see the detailed mechanism of carbylamine reaction. This carbylamine reaction is a very best example for alpha elimination reaction. So as I said, it is a best example of alpha elimination reaction. So this point is useful for you in any competitive examination. So now we shall look after how this alpha elimination reaction will occur in developing the corresponding isocyanide. So firstly, in step 1, the chloroform will react with one molecule of potassium hydroxide. So in this way, CH, Cl, Cl, Cl. So this is the chloroform. So one unit of OH minus will comes in reaction with chloroform. So this OH minus will attack the hydrogen of the chloroform, so that this H and this OH minus, this H will comes out in the form of H plus, and that will combine with OH minus. Obviously that results in the elimination of water. So this bond pair of electron will shift on to the carbon atom, so that we will be getting one unit of water will get eliminate, and that results in the formation of C. There is a lone pair of electron, Cl, Cl and Cl. Okay. So due to accumulation of this bond pair of electrons on the carbon atom, here the lone pair of electrons have been developed, and that creates a negative charge on it, that is a carbon ion. And this carbon ion will further eliminates one unit of chloride ion. One question may comes to our mind, why this chloride ion will get eliminate? The reason for the elimination of Cl as chloride ion is, here we have OH minus which is obtained from KOH. So when OH is coming out as OH minus, here we will be having K plus, and that K plus will receive this Cl as Cl minus. So this whole will come out. So the Cl will come out along with the bond pair of electrons as Cl minus by combining with K plus. So here we will be observing elimination of one unit of KCl, and at last we are going to get the reactive intermediate dichlorocarbene. Dichlorocarbene. So this is the reaction intermediate in case of carbylamine reaction that will be obtained in step 1. So you can notice the reaction which I have written in the beginning. So here we are observing that there will be consumption of 3 moles of potassium hydroxide, so that formation of 3 moles of KCl and 3 moles of water should occur. So here already we observed elimination of 1 unit of H2O and 1 unit of KCl. And in step 1 we observed that there is a formation of reactive intermediate, that is dichlorocarbene, and that dichlorocarbene now reacts with this primary amine. So that will be in this way, or NHH or NH2, and we will be having a lone pair of electrons on the nitrogen atom. And now this primary amine comes in contact with this dichlorocarbene. carbon. This carbon is electron deficient. So this lone pair of electrons present on the nitrogen atom will attack the carbon atom. So that we will get R, N, H, H, C, Cl, Cl having a lone pair of electrons on the carbon atom, but here nitrogen lost its lone pair of electron and having tetravalency. So here there develops a positive charge on the nitrogen atom. So to balance this positive charge, the bond pair of electrons present between nitrogen and hydrogen will shift on to nitrogen, and now this hydrogen is lack of electron, and those electrons will be donated by this carbon atom. So that we get one more reactive intermediate over here, or N. Once again the lone pairs have created on the nitrogen, H, C, H, Cl, Cl. So this is the next reactive intermediate, and now this lone pair of electrons which are present over here will shift between nitrogen and carbon atom, and because of this shift the K plus ion which is there in the solution will comes in contact with Cl. Therefore this Cl will come out in the form of Cl minus, and that combines with K plus and results in the elimination of KCl. So that we get R, N, double bond, H, C, H and Cl. But here once again you can notice nitrogen lost its lone pair of electron. So once again it gets positive charge. So to satisfy this positive charge, once again the bond pair of electrons present between nitrogen and hydrogen will shift on to nitrogen. But this H will once again comes in contact with OH minus. This OH minus will pick this hydrogen, therefore this bond pair of electron will shift on to nitrogen. So you will be getting R, N, double bond, C, H, Cl. So here OH minus and H has been combined, and that results in the elimination of 1 unit of water molecule, and once again they created a lone pair of electrons on the nitrogen atom. And now this lone pair of electrons will once again shift on to or redistribute between nitrogen and carbon atom, so that develops one more pi bond between nitrogen and carbon. So this carbon will get tetravalency due to formation of this bond extra, so this chloride ion has to remove, so that this Cl minus will comes in contact with once again K plus, so that this Cl will once again comes out in the form of KCl. So there occurs elimination of KCl. So we will be getting R, N, triple bond, C, H, but due to loss of lone pair of electron there developed a positive charge. But now this H left as it is, now there comes in contact with OH minus. This OH minus will pick the hydrogen, so that the bond pair of electrons will shift on to carbon atom. So finally we get R, N, triple bond, C. There is a positive charge on the nitrogen atom, and due to shift of this bond pair of electrons onto carbon, they developed a negative charge, so that we got the isocyanide as the final product. So now we shall analyze the reaction with mechanism. So here I have observed there is 1 mole of amine, 1 mole of chloroform and 3 moles of potassium hydroxide, so that we will be getting 3 moles of potassium chloride and 3 moles of water. So first we shall count the number of KCl. So here we observed 1, 2 and 3. So 3 moles of potassium chloride has been formed, and we should observe the formation of 3 molecules of water. So here there is 1 unit of water, 1, 2, and 3. So with the final formation of corresponding isocyanide. So this is the detailed mechanism of carbylamine reaction. Now the answer for the question which I asked in the very beginning, which I proposed, that is, this carbylamine reaction preferably gives answer only for the primary amines and not for secondary and tertiary amines. The reason for this particular thing is, if you consider the secondary or tertiary amines. So let me consider the secondary amine. So R, N, H, R dash. So this is the secondary amine. And if you go with the tertiary amine, R, N, R dash, R double dash. So this is secondary and this is tertiary amine. Why this carbylamine reaction will not give answer for secondary amine is, again notice over here, we are having only one replaceable hydrogen over here. But if you come to the tertiary amine, we don't have any replaceable hydrogen at all. When this secondary amine reacts with the reactive intermediate, that is dichlorocarbene, we are going to get only a bit of the reactive intermediate salt, that is this one. So here, in case of primary amine, we are having 2 hydrogens. But if you consider the secondary amine, we will be getting one more R group over here, but not H. And that will not undergo further elimination reaction because we are having only one replaceable hydrogen. And if you come with the tertiary amine, and here when this tertiary amine is made to react with carbylamine reaction, upon reaction with dichlorocarbene, what the inner salt we are going to get will be highly unstable one, and the stability is very less because of steric factors. Both the inner salts that are going to produce with respect to secondary and tertiary salts are stereotically highly unstable, and the unstable products or unstable reactive intermediates that what we are going to get in a reactive system will not lead to the formation of products. And that is the reason why secondary and tertiary amines will not give answer for carbylamine reaction. And one more thing, only the alkyl isocyanates are the materials that gives a foul smell, but not dialkyl or diaryl or trialkyl isocyanates. Only the monoalkyl isocyanates are the materials that gives foul smell. And that's the whole and sole thing about carbylamine reaction. In our next video, we shall see one more test which will be used for the distinguishing of isomeric amines, that is primary, secondary and tertiary amine. Here this carbylamine reaction is useful to predict whether a given amine is primary or not. But if the amine is secondary or tertiary, in order to find out whether the given amine is secondary or tertiary, we go with one more test that's called as Hinsberg reagent test. And regarding Hinsberg reagent test, we shall see in the next video.